Hi, Sam here from Roberts Geospatial. We're going to take a deep dive today into classified rasters and the new classify operation, processing operation in ProRaster Scientific. So what is a classified raster? Well, a classified raster is like a thematic that you might find in a GIS system. And in the ProRaster system, a classified raster consists of one concrete band that actually has data. That is the index band. It's an unsigned integer. It's zero-based, and it points directly into a row into the classification table. The classification table is a matrix of n columns by m rows, and it can contain all sorts of different information. So it can contain strings, for example, which is unusual for raster data. And the size of that table is pretty much unlimited. And it will usually contain at least two things. The first is a color, and the second is a label. So that when you display a classified raster in ProRaster, it detects that there's a color in there, and so it displays it using an image layer. It selects that color band, and then when you move your cursor over a classified raster, it will look for that label band in the table, and display that as the default value for the cell. And in this system, a classified raster, even though it's got a very different structure to a normal raster, it can be processed and treated just as though it's a normal raster. So you can do calculator operations on different bands in the classified raster, where it's pulling the data out of the table in order to get the band values rather than from some traditional raster matrix. So let's just have a look at some classified rasters. So I've got a little algorithm here with a few examples. So I'll move that out there. So firstly, this is WorldCover. So this comes from the European Space Agency. This is quite a high resolution global data set. And I think they've got developed for 2020 and 2021, but not very many classes. So you can see grassland, tree cover, built up. So very high resolution, but not a huge number of actual classes. Going back, let me turn that one off and turn on GlobCover. GlobCover was sort of a previous iteration from European Space Agency. So lower resolution, perhaps more detail in the classification, and that's global. Another example, here's the US. So this is a national land cover data set, and again higher resolution and more detail in the classifications. And finally, an example from Australia. So this is the catchment scale land use model for Australia, and also quite high resolution, but more detail. So for example, where this is defence facilities, and here's built up and grazing and so forth, and the different kinds of agricultural usage for the land is being recorded. So if we compare this Australian product versus, say, WorldCover, so here's for the same area. So WorldCover is much higher resolution, but if we turn this on and off, you can see that it hasn't actually got the same number of classifications. It doesn't really know what the land's being used for. It can detect what's on the land, so it's detecting trees and so forth, because it's all being generated from Sentinel-2 imagery. but it doesn't know actually what the land use is. So you'll find these global products are useful for telling you what's actually there, whereas the sort of national scale product that might be produced by your national mapping agency will give you more information about how that land is actually being used in all likelihood. So that's some examples of classified rasters in ProRaster. So next we're going to see how to build them. So there's a new processing operation in ProRaster Scientific, and it's called classify. And this is a classify raster operation. So it's going to take an input raster, it's going to apply the classification rules, it's going to augment that raster with a classification table, and then it's going to output a virtual raster, which is a classified raster. So the processing operation itself does nothing except output a virtual raster. Then it will be immediately displayed in the main dialog, and when you display it, that's when it starts doing the processing work in real time. So you will need to define a source raster, you'll need to define the output virtual raster destination, and then you need to provide two things. Firstly, you need a data transformation that will map the values in the raster to the row indices in your classification table. So we need a data transform. The second thing that we need is the classification table itself. So this is a bunch of rows and columns. Each column has a different kind of data in it. It might be some numeric data, it might be a string, it might be a date time, it may be a color. So they're the two critical things we have to supply: a data transformation and a class table. And there are two ways that this operation allows you to do that. The first one is to simply supply what's called a legend file. And the legend includes both the data transform and the classification table in a very simplified way. So that's an easy way to do it, but you get very little control, well, no control over the classification table, which will remain very simple, and also the data transformation is also limited in what you can do. The second way that you can do it is to define CSV files. These are in a special format, one for the classification table and one for the transformation, the data transformation. And we'll show you how to do that later on. And that provides you with a more flexible option. So you can put anything you want into the classification table, you can make it as big as you want, and you've got more options in your data transformation as well. But let's see how to make something from a legend file to start off with. Your first challenge is to create a legend file. Let's classify just a continuous raster. Okay, so we're going to classify a continuous raster. Let's just work with this global 3 arcsecond resolution terrain raster. So I'll go into the data transform editor, and we've got a transform here which uses Jenks natural breaks, and we've got 4 ranges. So that'll do. Let's hit the button and hit export to a legend file, and we'll call that merit Jenks. Hit save, and it automatically opens that up into your default text editor. So this is what a legend file looks like. It's got a begin and end, and it has a data type declaration, and there's a special code here that of which there are 4 different kinds, and you have to choose the right code. Then there's this legend block, and inside you've got the rows of your classification, or of your legend, but which will be turned into rows of your classification table. Now in this case, we've got a range of values. So we're mapping from 1,635 meters to 3,481 meters into this class number 2, and it will have this particular color. Now there are 6 zeros after this. Don't worry about them. The legend file is actually an old thing, and it actually defines a rendering style for polygons and lines and whatnot. So all that other information is not used, so we just put zeros at the end there. The only thing we're going to use is this color, this label, and this data transform. Let's just edit this a little bit. So this will be low lying. This one will be hills. This one will be alpine, and this one will be mountain, or let's say Himalayan. In here, just a little note on this color macro. So this is red, green, blue, alpha. It does include an alpha, and sometimes that alpha comes out as 0 in certain cases. And if it does, when you render the raster, you won't see anything because 0 is completely transparent. So you need to put a valid alpha value into that fourth channel of the color, or you can replace it with just an RGB. So let's save that. Hop out of there, go into our processing operation. So we're going to classify merit DEM. We need to choose the field and the band that we're going to target. Here's our output file. It's an MVR, a virtual raster. I need to set the data type for the index band. So the only thing that I need to do is to set a data type that's large enough to cover the number of rows that I have in my table. So this is an unsigned 8-bit integer. That will give you up to 256 rows. If you have more than that, then you can go for a 16-bit integer. That gives you up to 65,536 rows, and so on. There's an option here called classify failure index. So if your data transform, when it transforms from data to class index, fails and doesn't generate a valid class index, then in the algorithm that can be picked up, and in that case you can assign a class index to that value, in which case you check this on and you say, oh, I want this to be class index 3, something like that. Now we're going to load our legend table, hit OK, and straight away we have a result. And here we have low-lying, hills, alpine, and of course Himalayan. So there's our classified raster. So we still have a 3 arc-second resolution global raster, but instead of terrain we now have a simple index into a small classification table. And right, so now I want to give you an example of classifying a raster that is already a pseudo-classified raster. If you download any classified data off of the web, you're almost certainly going to get a TIFF file. And inside that TIFF file, there'll be some numbers, and they're your class indices. And then you'll get a document which will tell you what those numbers mean. Okay, so we want to then turn those numbers into zero-based indexes into a classification table and create a classified raster. So I'll use the example of Glo30. So here's a few more examples of using a legend file. So the first one is the water mask. So the water mask has values 0, 1, 2, or 3, corresponding to no water, ocean, lake, river. And in this case, I'm using a numeric data map. So I'm saying that 0, the value 0 in the raster, maps to the first index in the table. Value 1 goes to the second, blah, blah, blah. And And so that's a very simple transform, and I guess we'll see that in motion. So let's do a classify operation. We'll load in, so we want the WBM, let's say New Zealand. We want that WBM legend, which would be in here somewhere. I don't need to do anything else. I hit OK. And here's my classified raster. So we have ocean, no water in the land, and then lakes, and also rivers. So that's fine. Let's have a look at another example. Also GLO30 data. So this is the fill mask. And in here we map values through 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then it jumps up to 100, 101, 102. So in other words, we're mapping 100 to, in this case, index number 10 in this classification table. So in other words, we're sort of taking numbers that are non-linear and making them into a linear progression of numbers. So that's the fill mask, and then there's a third one that's supplied, which is the editing mask, and again list through to 13. So that's a numeric transform. So I want to talk briefly about building the overview pyramid for classified rasters. So I'm displaying here the water mask for the GLO30 data for New Caledonia. So I'll just zoom in a bit. So you can see here that we have land, and then we have river, a little lake there. Now, as I zoom out, you'll see an odd effect. And we'll go back and forth. So remember we've got red and blue, but at some point, at this point, I zoom out and the red and blue becomes red and green and blue. So what's happened is the overview pyramid has been constructed without taking account of the fact that this is classified data. So it thinks that it's just ordinary data, and it's combining data from cells in order to build the cell value for the pyramid at the next level. So the cell values are 0, 1, 2, and 3, and when you average, some of those values together, you'll end up with a value which isn't any of your starting values. So with classified data, you have to, when you build the overview level, you have to select an appropriate data value that's present in the underview level for the overview cell value. You can't go and interpolate anything, you can't do any kind of averaging or anything like that. But of course, that's absolutely the default. So as we zoom out, this data becomes a little bit weird. It's showing us classifications that don't actually exist in the base level because it's doing that averaging. So we don't want that to happen. How can we get around it? So firstly, go into your Raster source editor, and I'll go into New Caledonia WBM. Go into Advanced Properties, and in here you can set a couple of things. So firstly, I'm going to override the field type of the raster. It thinks that it's imagery, but it's not. It's just continuous data. So we're going to call it continuous. And then I'm going to override the band value type for the first band. And instead of having standard band value type, I'm going to give it the unique band value type. You have to add that into the list. So with these settings, when I construct the overview pyramid for New Caledonia, it will build the overview like it's a classified raster. Hit OK. I'll shut that down. Don't want to save that. Go back in there. New Caledonia WBM. Right, so we've got our advanced settings in place. Now we need to rebuild all of the pyramids. So I'm going to do a clean, and I'm going to delete all those files, and then I'm going to do a prepare. And now it's going to rebuild all of those cache files for the overview pyramids and statistics and so forth. Close. Now, if I display that data, we won't have the same problem. I won't go through and demonstrate that, but there's a second way to get around the problem as well. And that is, after you've run your classify operation and you've generated your virtual raster, what you should then do, and I strongly recommend that you do this, is that you then go into the export operation. You bring in your classified raster as a source and you export it from MVR out to MRR. So you're doing a convert. You're crystallizing the data and creating a new MRR format raster. And when you do that, because it's a classified raster, MRR knows what to do and it will build the overview pyramids correctly. So I strongly recommend that after you build these classified virtual rasters, you then go and once you're happy that they're correct, you go and export them out to an MRR for safekeeping and to make sure that those overview pyramids are correctly constructed. Okay, so now let's classify using the more advanced technique where instead of supplying a legend file, we now supply two files, one for the table and one for the data transform, the map, both in a CSV or comma delimited ASCII file format. Now in program data, RGE, Roberts Geospatial Engineering, you'll find that there's a file called classification table template, and this is an Excel file. So make a copy of that, and you can use that as a template to create your classification table. So let's just have a look at what's in this thing. So you have to follow this template. So the first row is going to contain a string, which is the name of each column in the table. And when you open this raster when you open the classified raster, each one of these column names will have become a band name, and you'll be able to select it for rendering and so forth. So you can add as many columns as you want. The template only has a few, but you can take some column and copy it and duplicate it as many times as you want. The second row, contains a special ID which tells ProRaster what kind of column this is, and in some cases it can use it to do special things. So this is actually a drop list, so there are only a set number of these special IDs, and you have to choose one. So mostly you will choose data, and that's not a special ID in the sense that multiple things can be data, and it just isn't really special. But the special ones are label. So you'll have a primary label, and that'll be used when you drag the cursor over the raster, and it will display the string that's in that label. You also have a color. So this is the color that will be used to render the raster by default when you display it in ProRaster. In addition to that, there are a few others. So firstly, class. So class is designed to store the original class value. So if my value in my TIFF file was 103 and I map that to row number 4, then I'd put 103 into this class column. So it just is a record of what the original value was before it was mapped into the classification table row index. Value is is just like data, except that it's the primary data value. So it's the most important data value in the table. And then if you don't have a color as a red, green, blue or red, green, blue alpha, you can enter color as color R, G, and B for the red, green, and blue components. So select one of those IDs for each column in row number 2. In row number 3, we're going to specify the data type for all the data in that column, and this is the way that it will be stored into the raster. And again, this is a drop list, so you can't just put anything into here. You have to select one of these strings or one of these IDs. So you have unsigned integers, 8-bit, 16-bit, 32-bit, signed integers, and floating point numbers. This is a 32-bit floating point real. This is a 64-bit double precision value. Date time values, strings of various descriptions. You probably just use a standard string, and also color types that you can use. So you need to select one of these things for each one of the columns. From that point on, you're going to put in all of your data rows, and you can put in as many as you want, and enter all of your information into each one of the columns in your table, and fill out your table. So that's what the classification table looks like. When you bring it into ProRaster Scientific, you have to save it as a CSV file. So in the original format, it's an Excel format. You don't want to keep that. You save it out to a CSV file. Okay, so here are some simple CSV files for our water mask. So here's my table. So the first row contains the labels. So we have original class, class color, class label, date time. The second row contains the special IDs that identify what these columns are. The first one is the original class value. The second one is the color that we're going to use to render it. The third one is the string, the label that we'll use to present that data to users. And the fourth column is just a data column. Here's our data type. Unsigned integer, 8-bit, red, green, blue, alpha. A string, normal ASCII string, not Unicode, just ASCII. You can also use Unicode, and then a standard date time. And if you look at our table, as expected, we have a number, and then we have this color specified as an RGBA within quotation marks because there are commas in this macro. There are a whole bunch of ways that you can specify colors, and look at the documentation to find out about that. Then the label, and then finally a date time. Date time is another thing that's very complicated and not very well handled in computing in general. There are a plethora of ways that you can specify the date and time. So many of them will work and so many of them won't work. Decoding these things is problematic. So again, go to the manual, the user guide, to find out how to express your date time. So that's my table. And then my class transform. So again, a very simple CSV file. So in the first row, and it's very much like the legend files that we were looking at before. So in the first row, you just have to declare what kind of transform it is. It will be numeric, in which case you're mapping a value or multiple values to an index. And that's a point of difference between this method and between the legend. So legend only maps one value to an index, whereas with this transform you can map multiple values to an index. Numeric discrete, where you've got a range of values. Numeric continuous, where you've got a continuous range of values. And there are your three options in the CSV file data transform. So here we're listing firstly the data value and then the index value. And these don't have to be ordered at all, so you can list them in any order that you want. But this is perhaps a bit obvious, but we're mapping 0 to 0 and 1 to 1, etc. So let's just see what happens when we do that. So we're looking at New Zealand water. We're going to specify these CSV files, which are up a bit, I think. So class table and our class transform. Hit OK. And here we have our transformation and have our classified raster. So again, as before, ocean, no water, lakes, rivers. So as we expect. Let's have a look at a slightly different one. So here we have a slightly simpler table. Actually, we should get rid of that and that. So now I'm going to map everything that's onshore to a class and everything that's offshore to another class. So in other words, offshore is going to be the ocean and onshore is going to be the land and the rivers and the lakes. So in this case, my data transform, again numeric, but now I've got multiple values all mapping to the first index, which is onshore. So that was so that's your land, and that's your lake, and that's your river, and they're all mapping to 0. And then 1, which was the ocean, is mapping to the offshore index. So let's see what happens when we do that. So we'll do classify with New Zealand. I'm going to define CSV file, simple class table, and this simple class transform. And now you can see that we simply just have two classes, onshore and offshore, and all of our rivers and lakes have just become onshore. So that is classifier in a very large nutshell. There's more detail, there's more devil in that detail. To find out more, download and read the user guide for ProRaster, and you'll find that it's all documented in there. Thanks for watching.